All right, thank you. I've found a way to do this.
Yes, sir.
Now
It
let
does.
me let me just see if I can. Uh, do you see the Forthmobile on the floor?
Yes,
Okay,
loud and clear.
excellent. Then I can share. Then I can share a window here. This one. And now, if I am lucky, you should see my screen, and you should see the Forthmobile in the upper right corner.
Exactly.
Exactly. Excellent. Okay. So if you look at this document, then you'll see how it's built. So it's built around a motor controller, some sensors, some pulse counters, some laser rangers, a compass, and this board that I've shown you before, this ESP32 super expander that I call it. So I'm just going to show the overview of how the software works. It has a low level part and a high level part. So the low level part interacts with all the various doodads that are connected to the super expander. For example, for motor control, for these registers that control whether it goes forwards, backwards. It also generates PWM values so that I can vary speeds. There are different ways of turning. For example, I can turn by running half the wheels forward and the wheels on the other side backwards, or I can block one set of wheels and run the others, or I can just adjust the speeds. That will change the way that it turns. So, and then for distance, I measure distance in millisecond travel at speed 150. But in order to find out how far that is, I can just go for that time and measure, and I found it to be about 30 centimeters if I run it at 1 second at speed 150. So this is the data that I'm gathering, and the control parameters that I use in order to manipulate the board. Then, in order to drive around, I have this state machine here. So normally it will be driving, and when it's driving, it will adjust. If it sees an obstacle on the left, it will turn slightly to the right, and if it sees it on the other side, it will turn the other way, etc. If it sees an obstacle in front of it, then it will go to a different state that's called obstructed. Then it will stop. It will try to back out. It will turn the laser rangers. It will activate the servos and look around for a way out. And this latest addition is a state that said that it's off course, that I've staked out a course for it, and then it looks at the compass to see if it's on course, and if it's badly off course, then it will go to this different state. Now, the way it is right now, these two states, off course and obstructed, they will fight each other. So it will try to get back on course. There will be an obstacle. It will turn away from its course, etc. That's something that I have to fix later on. And the way I'll do that is that I'll have two courses. One course that is set, an intermediate course that can lead around these obstacles, then I will have an overall course. So it will be instead of being one course, it will be an array of course segments that might lead around the obstacles that it finds. But that's I'm not quite there yet. But I am ready to share another screen. Now let me see here, and then I will share this one. Now, if I do this,
Now, Atle, we see only your black terminal.
you don't see text on a black background.
Yes, the text, but we have lost the FORTHMOBILE.
Oh, it's no longer okay. Then I'll go back and see if I can stop the video and then start it again. Do you
Now,
see it?
yes, okay, yes.
Oh, all right. Then I will try to execute this again. Do you see it going? You see it turning?
No,
Not
it's
moving for me.
not moving.
Static.
Now,
Now it's moving. Okay.
Yes.
Okay. So I can see now the desired course is 157. The actual course is 159, and it's turning left. It shouldn't. In fact, it shouldn't do that. It should go straight ahead when there's so little difference between it. But anyway, I can run for say 5 seconds. And then I need to and see how it likes that. Yeah. So now it went off in that direction for 5 seconds. I can see if I can get it to come back. And see if we're still on course. Yes. So let's see if we can run into an obstacle. We have the same desired course, but I will turn right. So that it's pointing in a different direction than the one it should be going in, and then see if I can run it for 15 seconds. And you see now it's trying to find its course, but it's crashing into something, and it probably, yeah. So so the way this works is if I give it this command gear backwards, then it will go backwards forever. So I need to give it explicit order to stop, but I need to give milliseconds, because otherwise it will just stop immediately. Now it should go backwards for 1500 milliseconds, and it did, but it's got its wheels tangled up in something. I will see if I can help it. Oh yeah. Oh man. Oh, it it managed to wedge itself under that furniture. That's why it didn't move. Okay. Yeah. Let's see if we can try it again. So. Of course, and now we run for 15 seconds and see if it can get back on course. It did. So it found its course and now it's off. It's going off towards the entrance door. And that's, yeah. Oh, now it's collided with the entrance door. I see that. If you look at the log here, you see that it's obstructed. It's trying to back up and trying to find. It's trying to find a way through the entrance door now. That's basically that is the status of this project as it is now. Let's see if I can get my ugly mug back on the screen. And that's it. That's the status of the FORTHMOBILE. All the
Very good. Fantastic.
yeah, the documentation and code and everything is up on GitHub, and Peter has given me access so I can put it up on the Forth website as well. As soon as when it's good enough to go there, I will put it there. Yeah, thank you.
I think Rob Probin and William Overkirk are the specialists here in robotics, together with Joss, of course, and Ulrich and everyone else. But probably Rob and William can give you some feedback.
Very good. Love it. More robots, the better.
Yeah. Yeah, I'm trying to. I will be attempting to draw a map for it and try to implement the A-star algorithm for going into the kitchen and coming back again. Yes.
Yeah. Good.
I have one
forward to it.
question. So would it be reasonable, instead of giving times to do the movements, talking about distances and angles? Like turn 90 degrees to the right.
Yes, well, I did something horrible when I designed that PCB. I left. I have some registers that are cascaded. So the serial in on one goes to or the out from one goes to in on the next one, etc. It's just that on the first one I forgot to ground it, so it's shifting in random bits, which makes all the data that I get for the status of the wheels, it's garbled. So I have a new board that's coming in now in a few days, and also I will solder a little strap onto this board to just ground that input, and then I will be able to measure distances more accurately.
Yeah, so then you would measure back the turning of the wheels, so that you can do closed loop control there. Yeah, great.
What type of encoder do you have on the robot? Remind me. I think I've looked at your robot before, but
I have this. I think I should even have one here. Those are IR encoders with a. So there's a slit in the wheel, and every time there's it passes through this opening, then I get a pulse.
Okay.
And these pulses then go into a 4020 counter.
Yeah.
And they are being stored there, and that 4020 counter is then connected to a 165 register that shifts it into shifts it into the ESP32, so that
Okay.
I can
Good.
read this whenever I want. So I don't have any interrupts or anything like that. I just read the values.
Yeah.
Something I want to remark, that Atle created his own board from nothing. He had no electronics knowledge 1 year ago. He had no knowledge of force 1 year ago. He prints with the 3D printer many parts of this kit. He makes the Java interface. He talks to the FORTHMOBILE over a own design of a terminal. So I would like to know more Atlas. We have only one in the group, and
Yes, fantastic.
if someone knows more Atlas, we will be very happy.
Very
Yeah.
impressive.
Indeed.
But yeah, with
Well,
robots, often you're dealing with mechanics, electronics, software, real-time
Exactly.
software, and it's hard. Obviously, you know, I'm involved in a robotics group, and it's difficult for beginners to do everything. That's the problem. You know, you have to do mechanics. You have to understand inertia. I mean, but it's interesting. It's very interesting.
Yes, I mean, I was a Java programmer. I was programming, you know, the administrative software, and when I put a value somewhere, that value was there, and there it didn't. There were no voltage levels or nothing that could burn or blow up or crash or anything. Yeah, the worst thing that could happen would be some kind of exception, and then I could just go in with a debugger and find out what it was that I did wrong. So the level of catastrophe that can happen here has made me more disciplined. I look a lot closer at my code now than what I used to do.
Yeah.
I think Francois want to build one of these kits, and probably Christian Hintze. I know that Jos Venn has also one of these robots, these smart cars.
Well, I think the interesting thing that we saw in your demo, thank you very much, Atle, is the interactive nature of Forth. So if you compare this with the way that you would program the robot using C, for example, yeah, then it wouldn't be as easy. You would have to program some kind of command loop that you can press F to go forward, or it asks you for the number. This is all what gets us for free with the auto interpreter. So showing and exploring things in this cyber physical thing, yeah, where you have hardware to control, where you have software, and also if you're doing electronic development, it's the same thing, that you can actuate parts of the circuitry and figure out what's going on. So I think this is where Forth shines. But also what we saw is the drawbacks that Forth has in that, well, you missed milliseconds. You said 1,500 stop. And so if we do errors, we see them immediately, which might be nice, but the damage could be serious. And so there is no safety net. And I think that's something that we need to think about. Also, Bill said that writing the string append routine was more work than he expected. Well, as being an old Forth programmer, that surprised me, of course, but it's the same experience that others tell me as well. In the end, it's nice program and it looks like Forth, that's great, but it's not as easy as it should be. And I think that's we as a community can think about this. So how could errors that Atle did by demonstrating, how can we avoid this to make things not catastrophic if we mistype. So I know it's crash early, crash often, so that you learn about your programs, but I think that's not always a good option.
I'm not so sure. I'm not so sure, in fact, that we should be protected from all of this. because it does something to the way we think. You know, when I look at Bill Ragsdale's, it's like watching poetry. You know, it's terse, it's beautiful, it's the only most logical way of dealing with a problem, and if we were protected and guided and babied around like we are with these Java IDEs, I don't think we will be able to fully realize our true potential. So Forth is also, it's a form of meditation.
It's a balance that you have to take. So I would propose to have like something like IntelliJ for Forth, to shield you from everything that could go wrong. But there is probably some middle ground. Instead of crashing the robot or burning the circuitry because you just mistyped something, yeah. So you of course you can and you will and you want to shoot yourself in the foot in some way, and this will always be the case. And yeah. So, but if we have techniques to do what we want, that would be great. And if things are really getting simpler.
You could use the catch and throw mechanics of Forth, and then you can catch a lot of errors.
For sure.
But that keeps a problem when you're using hardware and circuitry. So you have to some kind of decouple couple it with the software, measure the current or something like that. So you can keep the system safe.
Yeah, to prevent crashes, I have all these IR sensors that ideally should be mounted all around it, and I also have some tilt sensors, and I can plug all these onto the board. But I realize I forgot something Don Golding has been speaking about when he's speaking about his triune operating system, that not all of this should go to the CPU. Some of it should go directly to whatever powers the wheels. So that's probably something I'm going to change when there's a revision war coming up.
I am the lawyer of Atle, and I will come to his defense. I will defend my customer. This is very easy to resolve, and I will advise him after the meeting to make a small cradle to put this FORTHMOBILE. It's not necessary to run in the ground, but he can touch the sensors from the distance because he has a laser sensors. And he can see the wheels spinning in the right direction, etc. When everything is okay, then he puts the FORTHMOBILE on the ground and it will run.
Yep.
This is not a big problem. But Atle's problem is because he makes everything. He was a couple of days ago with the PCB board problems, so he must solder and find the cold solder and this kind of problems. But I think this project is fantastic for the community. In a couple of months, this will run like butter.
Yeah, great. So are there any other comments or questions to Atle? Well,
Murshid had a question in the chat here.
Right. Yeah.
Well, it won't heat up. It will simply run out of battery. If I took this out on the football field and let it go and lost contact with it, it would run until it was out of batteries, but it wouldn't overheat.
All right. And then there's another question that he asks is like why you don't use a camera.
I have a project with a Raspberry Pi and a Cadas Vim that is powerful enough to be able to interpret data from a camera. The ESP32 and have the ESP32 interpret the data that it sees. It's really on the brink of what it can do. It can recognize objects, etc. But to be able to process this in real time, I wouldn't do that with an ESP32. But with a Raspberry Pi, yes.
Okay, great. I would say so. Thank you very much, Atle. Again, looking forward to the progress of your robot, and we see it blinking in your background. That's so great. Yeah, wonderful. So.